In this second tutorial, we will expand binomials using the binomial theorem. So flip over to this part of our notes, and here is our binomial theorem. Now, what the binomial theorem will do is it will find a specific term of a certain binomial expansion. I'm going to use x plus y raised to the nth power. The binomial theorem will find any specific term, and what we'll plug in, we'll either be given this is a combination, the n choose r, n things chosen r at a time. Sometimes this symbol is also written in parentheses with two numbers, top and bottom like that. Both of these symbols mean the same thing. And the way to, you're not going to find this on the calculator, you'll find this. To do that, you go to Math. I'll write the notes down and then I'll show it to you. And then over to the, sometimes it's just PRB, sometimes it's PROB. Go over to that and it's number 3. You might have done calculations, or excuse me, combinations and permutations in your Algebra 2 class. So when we turn on our calculator and go push the math button, there are 5 menus up here. We're looking for the probability menu. So I'll push left, left. That gets there a little bit faster. And number 3 is the combination button. I'll push number 3, and then I can put my numbers in however I need to. So that's how you find that on your calculator. What this will give you is the coefficient. This part right here of our binomial theorem is the number, is the coefficient, basically the number that would have come from Pascal's triangle. You don't need to memorize this formula, you just need to know how to plug this into your calculator. The other two parts, of course, give you your variables and what powers they are. N minus r, you just take the number n minus r or n minus r. That will be the exponent of your first variable, x in this case. And then r, which is just this bottom number or this right number, will be the exponent for your second variable, which is y. So that's your binomial theorem, and it will find a specific term. So let's find each term for the expansion. The good news about this is we don't need to do the entire expansion. We just are looking for a specific term. So let's look at 5c2. What that means is I'm raising to the binomial to the 5th power, and that 2 is my r. So let's plug this into the calculator first. I already have the calculator waiting for me. I've got my 5, and then I'll arrow over to the 2, and then I've got my thing. If you have an earlier version, then you'll have to push the 5 first and then go to math and probability and pull up your NCR. So when I push enter here, I get 10. Yay. So the coefficient is 10. Now let's figure out what my variables will be. It says that x, your first variable, will be n minus r. The exponent will be n minus r. And that, of course, is 5 minus 2, which is cubed. And then my second variable simply has this power. So this is the term that I'm looking for. And if you recall from the first tutorial, that actually was in the previous binomial expansion. 10x cubed y squared was right here. 10x cubed y squared. It makes sense that it's one of the terms for raising to the 5th power, because that's what n was. But notice that it's the first, second, the third term. Now the question is, why is this the third term? And we'll come back to that question in a minute. So let's look at our second example. This time it looks a little bit different, but it's the same idea. Instead of 5c2, this is 10c3. So plug that into your calculator to see what you get. Pull up my calculator. I'm going to type the 10 first, since that's what comes first, then go to math, and then over to probability, and then down to number 3. And it'll put the 10 where it's supposed to go, and then I'll put the 3 there, and I'll press enter, and I get 120. So 120, and then my first variable is going to be 10 minus 3 to the 7th power, and my second variable is going to be simply to the 3rd power. So that is my specific term. If you expanded Pascal's triangle all the way down to the 10 row, you will notice that this is the 4th term. And now here's the question. So why was this the third term and why is this the fourth term? And the hint is always with what r is. You see that r is 2 and that refers to the third term. You see that r is 3, that refers to the fourth term. R is 1 less than the term that you want, than the term you want. And what I mean, or why this is in Pascal's triangle, remember that first row is actually from the 0 power. So 5c0 gives you your first coefficient. 5c1 gives you your second. 5c2 gives you your third. So r is always 1 behind the term that you're looking for. So I know in this third problem, if I'm looking for 12c2, since r is 2, this will be the third term. And this one, 12c10, this will be the 11th term. R is always 1 behind the term that you're looking for. So why don't you do this? Let's plug this into the calculator. 12c2. Now we're talking about the 12 row of Pascal's triangle. And I believe you get 66 on your calculator. You can check that. Your first variable is simple to find. The exponent is 12 minus 2. Just subtract those two numbers, we get 10. And then we know that the two numbers have to add up to 12, and that's why the other one's going to be 2. But this is the third term. And then let's do our final problem. 12c10, plug this into your calculator. You know what's weird? You also get 66. Now how could that be? How could 12c2 be 66 and 12c10 also be 66? Well, the reason is because we're talking about the same row in Pascal's triangle, the 12 row. And remember that the rows are exactly symmetrical. So that if it starts off with a 1 and then a 12 and then a 66, it will eventually come back down symmetrically to 66 and then 12 and then 1. So it does make sense that on each side of the 12 row, we get a 66. X to the, subtract these two numbers squared, and then this number is the second exponent. Now, which term was this again? Since we used a 10, it must be the 11th term, because there's always that extra term because of the 0. In the 12 row, there are 13 terms, and 12 choose 0 gets you your first coefficient. So this is a way to find each specific term rather than the entire expansion. So let's flip over. We've already done example 2 in the previous tutorial, and I think since we're looking to expand the entire thing, I think using Pascal's triangle makes sense. We could use the binomial theorem and find each term individually, but if we're going to expand the whole thing, I'm going to use Pascal's triangle. It's a situation like example 3 that I definitely would use the binomial theorem. This says find the 6th term. Just one specific term for this expansion. I do not want to take Pascal's triangle all the way down to the 8 row, find all 9 of those terms, and then count out to the 6th and circle it. That's a little bit too longer than I want to spend on this problem. I want to just find straight the 6th term. So the first thing we need to know is, what is our combination going to look like? Well, I know that it's going to start with an 8 because we're raising to the 8th exponent. And then what is it going to be right here? If I'm looking for the 6th term, remember, we're plugging in a 5. Always one number behind the term that we're looking for because of that darn 0. So we have to put 8c5 into our calculator, and you can go ahead and do that. Plug 8, choose 5 in your calculator, you get 56. Now what we need to do, and I'm going to color code, is take our first variable, which is not x this time, it's a, and raise that to the exponent that it's supposed to be, and that's 8 minus 5, which is 3. And then the second the second variable, which is 2b, I'm going to raise 2b to the 5th power. Now, a couple ways that you can check this. You could just remember it, that 8 minus 5, of course, is 3, and that the 5 goes here. But you could also make sure that the degree of this term equals 8, because if we're raising to the 8th power, the degree will be 8 in each of the terms. Okay, so that's our setup. Now we need to do our math. So we're going to do our 56, of course. This becomes a cubed, and this becomes 2 to the 5th, which is 32, and b to the 5th, which is b to the 5th. Multiplying all this together, which is the 56 times the 32, we get 1792, and the a cubed and the b to the 5th. This is the 6th term for this expansion, and a whole lot faster way of finding it than Pascal's triangle. So example 3b is asking the same sort of question, but asking it a little bit differently. It says find the a to the 6th term for this expansion. Same expansion, but this time we're not looking for, well, we're looking for a specific term, but we don't know which term to find. It's the term that would have a to the 6th in it. This term has a cubed in it. We need to find the term that has a to the 6th in it. So I need to know which term we're talking about. Is that the first term? Is that the 7th term? Is that the 4th term? I don't know. Well, a to the 6th follows the pattern. The first term would have a to the 8th. The second term would have a to the 7th. And of course some other stuff, coefficient and some b stuff. The third term would have a to the 6th, because remember the exponents will start to decrease from a to the 8th and then 7th and then 6th. So that's the term that we're looking for. We're looking for the third term. So I'm literally counting down either on my fingers or writing it out here to see that we're talking about the 6th term, excuse me, the third term. A to the 6th will be in the third term. So that means that my combination is going to be 8 choose 2, because if I'm looking for the third term, I'm using a 2 right here. Plug this into your calculator and you get 28. And then we need the other two parts. I've got my first variable, which will be raised to the 8 minus 2, the 6th power. And then I've got my second variable, 2b, which will be raised to the 2nd power. Now we just have to multiply all this together. We've got 28. We've got a to the 6th, of course, is just a to the 6th. 2 squared is 4. B squared, of course, is b squared. Multiply the 28 and the 4, we get 112, and then the a to the 6th and the b squared. We found the term that has a to the 6th in it. So notice the difference between these two problems. I might be finding a specific term where I say it's the 5th term or 4th term or 6th term, or I might be finding a specific term that has a certain degree of the variable, a to the 6th, and you might need to count it out to see which term that is and then go with your math. So I'd like to end this tutorial with one last challenge question. I'll call it try 1. I'm going to ask you to find a certain row of coefficients. I'll tell you that in a minute so that we all have the same amount of time. And I'd like you to time yourself to see how fast it takes you to find that entire row of coefficients in the correct order. Now, you don't get to go back to the previous Pascal's triangle that we've already started. If you're going to use Pascal's triangle, you need to start from scratch with the very first row. If you're going to use binomial theorem, that's fine. You can use your calculator. What I'd like you to do is, and you can pause the video, I'd like you to find as fast as you can the 9 row of coefficients. Pause now, time yourself, see how fast you can get. So here is my answer, and I got this in just under a minute, I guess. I know I'm looking for the 9 row, so of course I didn't have to think much about the first term, which of course is 1, and then the second term, which of course is 9. I did not know the third term, so I did 9 choose 2 to get 36. I did not know the fourth term, so I did 9 choose 3 to get 84. I did not know the fifth term, so I did 9 choose 4 to get 126. And that's all the math that I needed. I knew that in the 9 row, there would be 10 coefficients. I've already found 5. I know that these rows are symmetric, so I just counted back down, 126, 84, 36, 9, 1. Got it in about 50 seconds. So that's pretty cool. You could have expanded Pascal's triangle all the way down to the 9 row. I'm interested to know how long it would take you to do that. Or you could use your binomial theorem like I did. But understand, you don't need to use the 9 choose 0. Of course that's going to be a 1. Where the 9 choose 1, of course it's going to be a 9 because we know that the 9 row would start with a 1 and a 9. The 17 row would start with a 1 and a 17, and so on and so forth. So thanks for watching that, and I hope you did well with that try. I'd like to compare the times when we get to class. See ya.